Okay, let's look at logarithmic functions, right? So here's the definition, right? We say y equals log to the base b of x, right? If and only if. So this is defined, right? So the definition of log is basically log is the inverse function of exponential function of the same base, right? So base is b. So let's visualize this. So it's an inverse. So let's say log function goes from x to y, right? So this is a log function, log to the base b of something, right? Then its corresponding exponential function goes backward, right? So that's going to be a b to the some power, right? So if log function goes from x to y, then the exponential function goes from y to x. So we just have to write that. So base is going to be b, so it's going to be to the, right? Y is going to go back to x, right? So this is the definition, right? So let's look at an example, see if we can apply this definition. Right? Log is a little too difficult. Why don't we think in terms of exponential function, right? So base is 3 right here. So it's going to be 3 to the, right? So log goes from 27 to an open box. So the exponential function goes from open box, so 3 to the open box is equal to 27, right? But to remember that the 27 is 3 times 3 times 3, so it's going to be 3 cubed. So you know that 3 goes in the box, right? So therefore, log to the base 3 of 27 is 3, right? Let's look at another example. How about the log to the base 2 of 1 over 16, right? So let's do it that way. Rewrite it in terms of exponential function. So base is 2, right? 2 to the open box is equal to, right, 1 over 16, right? Right, first, 1 over 16, I don't like a fraction, so I'm going to write it as 16 to the negative 1 power, right? But 16 is, remember that it's a 2 times 2 times 2 times 2, so 2 to the 4th. So this is going to be 2 to the 4th is same as 16, and you have to raise it to the negative 1 power, right? So you can just multiply the powers. So it's going to be 2 to the negative 4 power, right? So we know that 2 to the negative 4 is equal to 1 over 16, so it's negative 4 is the value. All right, so that's how you evaluate log expressions. Logs generally a little too hard, so we just think in terms of exponential functions. All right, so since log functions are inverses of exponential functions, we can easily sketch the graph of log functions. So let's look at the example. Y equals log to the base 3 of x. All right, so the corresponding one is going to be the y equals, right, 3 to the x. All right, so that's the corresponding exponential function of the same base. All right, so we know how to sketch 3 to the x. So that's just 3 is bigger than 1. So it's going to be an increasing exponential function. So it's going to be an increasing graph, which looks kind of like this. All right. All right. So if you want to find the graph of, sketch the graph of its inverse function, we can just do a reflection about the line, y equals x. So this is our line, y equals x. So this is y equals x, right? We just have to do a reflection, right? So reflect it over here. So I think it's gonna look somewhat like this. So I'm gonna go here. Oh, let's see, I'm gonna redo that. All right, so go here and go somewhat like that. All right, so this is the graph of y equals log to the base 3 of x. All right, notice that remember that the domain and range of the exponential function is, let's see, domain was all real numbers, so domain is from negative infinity to positive infinity, right? The range is, since the entire graph stays above the x-axis, it's all positive real numbers, so from 0 to positive infinity. All right, since we are looking at this inverse, so log function is going to have, remember that we have to switch the domain and range, so domain of the log function is going to be all positive real numbers, right? You can see that from the graph. You can see that the graph is only on the right hand side of the y-axis, which is a positive x values, and the range is going to be all real numbers because the domain of its inverse is all real numbers. Right, so you can see that domain and range is switched around since we're talking about inverse function. All right, and one remark that there are certain bases used more often than others, and the first one is called the natural log. For short, I guess for lazy mathematicians, we have a short notation for everything. A natural log of x is ln of x. This is when the base is e. So this is very convenient. So if you have base e, then so this is a log to the base e of x. Then its short notation is natural log ln of x. Right. Sometimes you don't write the base. Then this is assumed to be the 10. The base is going to be 10. So log of x is actually log to the base 10 of x. This is another commonly used log, and it's called the common log. All right, so this was the definition of a log function, which is just the inverse of the corresponding exponential function of the same base. Oops. And the graphs of functions. We know how to sketch the graph of functions because we know how to sketch the graph of inverse function of any function. All right, that's it. I hope that this was clear.